Welcome, everyone. This is going to be Next Level Git, a lunch and learn. Oh, do you want to introduce me?
Kevin Boss, senior software engineer, architect, all around good guy at DevOps, Microsoft MVP. And what I learned in the last few weeks about Kevin, you invite him to your meetup and you get many, many new members. So thank you, Kevin.
If people are interested, QR code in the top left, that will give you a link to download this slide deck. There are links in these slides for what you want. We will probably post out that link at the end as well. So full disclosure, I am a GitKraken ambassador. The link that you see in the bottom corner is my GitKraken referral link if anybody is interested in trying it out. So just to say, my opinion may be slightly biased, but I've also spent time evaluating the other tools, and I still firmly believe that it is one of the best Git tools on the market. So definitely worth checking out, and it's going to probably show up a few times here. Before diving in, this is going to be targeted at a little bit beyond Git basics. So for people who may be unfamiliar with Git or source control, some of this stuff may go a little bit high up over the top. For everyone else, hopefully this takes you beyond the basic push, pull, commit. We're going to actually do some more interesting stuff with Git and see what is possible. For people wanting, if you aren't familiar with a lot of some of the basics or you're wanting a refresher, I cannot highly recommend the Foundations of Git course enough. It is a free course that you can go through. You get an awesome certificate at the end. There's a large mix of videos versus reading versus questions and quizzes to go through and answer. You can also get a nice little certification at the end as well. So if some of the stuff that I'm saying doesn't make sense, you're confused, you feel like maybe you missed something in the basics, highly recommend that you check that out, learn.gitkraken.com. Again, free certification course. It is wonderful. Definitely highly recommended. Okay, so before diving into some of the fun stuff, we have to kind of start a little bit with some of the basics. So, and starting off of what is a Git commit? So there's the short answer of this is a Git commit is a snapshot of your repository at a given point in time. A lot of times Git tools will show you a commit and they'll just show you like the deltas of what is inside of the commit, of what was changed to reach that particular snapshot. But the actual contents of in there are the entire snapshot of your repository. So if you are at a particular commit, you have a full folder filled with files and changes at your repository. A commit has an ID known as a hash. And it's kind of important that the name is referred to as a hash because that is made up of the contents that are inside of your commit. So by definition, then, that means if any of those contents change, the hash is going to change as well. Right? You can't make a change to something inside of your commit without that hash changing. But that hash is also the ID by which that we reference a lot of commits. And then the next sort of important one to understand is what is a Git Ref? And a Git Ref is just a friendly name that we use to reference a commit. So most people are familiar with, say, branches and tags. These are Git refs that point to particular commits. If you go and check out your dev branch, for example, that dev branch is going to point to a particular commit, and it has a friendly name called dev, and away you go. Branches and tags obviously have slightly different behavior in when they move forward versus stay fixed, but at the end of the day, they still are just a ref into a particular commit. And there are a couple other well-known ones like head that we'll talk about as we move that around, which is just a fancy name for where am I currently at. So all kinds of jokes about losing your head. They're great, but I'll save those for the Halloween presentation. Okay. Again, I'm going to kind of skim over a lot of the Git basics, but just calling out a lot of the confusion that comes around. And I just realized how fast that animation's going. I apologize. This has been great. With doing merges, this is oftentimes when people start working with source control where a lot of the confusion comes from out of the gate. What is my branching strategy? How do I get changes from point A to point B? And you will find plenty of debates online. Should you rebase? Should you merge? When should you pick each? And there's pros and cons. There's not, with Git, there's not one answer is always right. There's never going to be a, well, you just do X, Y, and Z, despite what some Stack Overflow articles say. You can't just follow some predefined script and have it always do the right thing. That is not going to work for you. You have to understand how Git is actually functioning. And the important part to note is Git is just a directional acyclic graph, right? Which means you have nodes, you've got vertices, and they will never contain circles, right? The lines always progress forward, which means you can show them in a hierarchy. Things like GitKraken show latest at the top, other tools show the graph in different ways, but all of these operations around merges is just manipulating those nodes and vertices of just how do I bring those things together? How do I draw those lines? So with a Git merge, the important thing to note is unlike most of those commits that will typically have a single parent, you'll note all those open circles. There's exactly one line out of the bottom of them, and you can follow them straight down. So in this case, if you picture a family tree turned upside down, the parent is the one directly below you. A Git merge gets different. So in this case, rather than only having one parent, a merge actually has two parents where two things come together. The advantage of your Git merge is you end up preserving your history. So in this case, the merge commit lets you see all of the history of your side branch. And in most cases, when we're doing development, what you will have is that main branch, the green one that tends to be linear going straight up. Developers break off, they do their work on a feature branch, which is your blue line, and then things get merged back in. The disadvantage is you end up with all of your merge history, which may or may not be what you want. Again, this is where there's not a single bullet for everything. Do you care about your feature branch's history? Ideally, developers are making commits consistently, often, at any point where things are in a reasonable state, or at any point they just want to make sure that they have a nice, easy fallback point too. Some developers are diligent about cleaning up their feature branches. Other ones, maybe they've just made commits every couple hours, and a lot of their commits are work in progress, work in progress. Ooh, it's finally working. Fixing broken tests. Okay, now merge, right? Like that's, I mean, people are laughing, but that's a lot of feature branches commit logs of how the development process ends up going. Do you want that history? Sometimes those feature branches history is important. There's various branching strategies. I'm not going to spend a lot of time diving in on them, of various Git flow, GitHub flow, whichever one you want to use. And they're all around defining a set of rules about when do you merge, when do you squash, when do you preserve history versus when do you throw away history? And the answer is always it depends. To go along with that, this is the operation that I think I run into the most questions on from people of in the Git rebase versus Git merge, I'm a rebase guy. I love my rebase. I love force pushing other people. Yeah, there's people in the room shaking their heads. You can tell who's on the other side of the fence on this discussion. This is going to be biased opinion for a moment. But it still is important to understand what the rebase is actually doing. So in this case, your blue line is your feature branch, and it starts based on that very bottom commit on your main branch, which is perfect. That's the point where you just said, okay, I'm making my new feature branch. I'm going to start work. I've done my work in progress, fixing broken unit tests, ready to commit. But at the point I go to merge back into my main branch, I now have conflicts. And this is where things get interesting. Is, somebody else edited the same file, same lines that I was touching. I added a using statement. They deleted a bunch of using statements. We've got a conflict. How are we going to resolve it? The merge commit, you have a small advantage because you resolve the conflict at the point where that merge occurs. And so you kind of see those two things coming together, and functionally it kind of makes sense. With a rebase, you get to time travel. Is you pretend like, well, I didn't start my feature branch last Friday. I actually started that right now. And so I'm going to reset myself to the top of the main branch, and then I'm going to redo my changes one at a time. Now, the important part to note with this, you'll note those commits are changing. And just like we said at the beginning, that's going to change your commit hash because those commits are now brand new. Git's just helpfully replaying those one at a time for you, starting from the new point. And for fun, if each of those commits would have caused a conflict, you get to resolve that conflict multiple times in a row, which is exciting, which is why some people will absolutely abhor rebasing. So rebase can add you a nice linear strategy. The other thing is before a rebase, especially if I'm working on a feature branch, I will oftentimes squash those commits into a single commit. That eliminates the problem of dealing with the same conflict over and over. And I'm resolving the conflicts exactly as they appear on my PR screen. So whether you're in GitHub or DevOps, when you open the PR, you're getting a view of my feature branch into the main branch. And if there's conflicts, then the question is, how are you going to solve them? And some people will then do the spaghetti approach of, okay, well, I'll merge main back into my feature branch, going the other direction. I'll resolve the conflicts at that merge commit, and then I'll PR back across. And then you end up with this fun spaghetti mess. And if that's where it ends, and your branch policies allow it, great. It's not a big deal either way, right? It's, do you care about that history and how do you want to resolve it? Again, I am on the rebase side of the fence. There is no one right answer. You can feel free to go either direction. Again, though, my trick is I squash my feature branch because typically I don't care about the commits in my own feature branch. They're oftentimes work in progress. I don't care about that history. I'm the author. I know whether that history matters. I'll just squash my stuff together and then rebase on top.
So what you're saying is, rebase, you have one node that you're playing on top of the latest.
Correct.
That doesn't necessarily resolve merge conflicts.
No, it doesn't resolve the merge conflicts, but it means I only have to deal with them once.
Pulling from main into your feature branch.
Correct. I'm not pulling from main into my feature branch. So unfortunately, thank you, GitKraken. I poached their animation. And they don't have one showing a squash before a rebase, but that is generally the workflow that I prefer is squash all my stuff down, rebase. It doesn't solve the conflicts. And in fact, as soon as I rebase, I should see the exact same conflicts that my PR showed in GitHub or DevOps, right? Because they'll flag you, hey, the following files have conflicts. They're still in conflict, but now right. But rather than the rebase replaying those commits one at a time and me potentially dealing with conflicts at each step of the way, because you could have a branch with 13, 14 commits on it, and that can get real annoying going, okay, resolve conflicts, continue, resolve conflicts, continue, resolve conflicts, continue. You can also merge back and forth. Correct. It's again, you will find arguments back and forth for both of these. For long running stuff, I find the merging gets real. Like if your branch is, again, if you merge back, solve the conflicts, PR in, done, great. Like there's not a huge argument for either side, right?
But really, what's the practical implication other than having a messy graph?
Depends on when your PR merges in, whether you are squashing there or not, right? So because again, depending on the branch strategy of your repository, when that feature branch merges into your main branch, if you keep all of that history and you just do a merge commit, now you end up with this weird back and forth stuff. And it gets really complicated, especially when you're trying to figure out where a change got introduced or where maybe a merge conflict happened. Correct. It gets real hard, real fast, the more spaghetti you have. Again, sometimes it's clean and it's not a big deal. And if you're going to squash the PR on main anyway, it doesn't really matter how messy you've made your feature branch. At the end of the day, you end up with a graph that looks like that.
Hey, Kevin, you got a question online.
Oh, thank you. My question monitor is thank you. Sorry, I saw a hand up. Yeah, go.
I raised my hand, Kevin. Hey, my name is Rodrigo. I'm curious as to what is your approach to metrics with respect to when an engineer starts working on a feature and he closes the feature. With rebase, you lose all that history, then you can do that metric. Do you have a way to make up for it?
I guess that, so not really, but I also don't put a lot of faith in that same metric as well. Oftentimes, we would be measuring the metrics using the work items, not the Git history, for effectively, because it sounds like what you're looking to measure is almost developer throughput, if that's correct, of how much is actually getting
Yeah,
done.
yeah. Yeah, and not only throughput, but what we want to measure is, sometimes engineers, I'm one of them, work on these issues forever.
Yep.
And that's not a good practice, right? So we want to
Yep.
make sure that we try to collapse the amount of time engineers spend on each issue, which forces us into think about defining smaller issues, et cetera, et cetera. And
Correct.
if without that kind of metric, I have run engineer organizations with very many engineers, and becomes very useful to sort of get a sense of where teams are going. But so I like the feature branch. I really like it, but I loathe missing that metric. I really do.
Yeah, and like I said, I think I would typically measure the metric with the work item itself rather than the repository. Because Git is so malleable in terms of where things go. Using it as a way of measuring developer productivity metrics, like I said, I would tend to favor pushing that less on the repository and more on the work items.
Thank you.
So if you're looking to, reduce the time that a developer spends on a specific work item, after that work item is complete, go and work with the developer to figure out how you can split that into smaller subcomponents that may be able to get done faster, and you can then see that throughput easier.
Yeah, and like I said, ultimately at the end of the day, the difference between these two can often just be the difference of which one makes the developer more productive. For an actual production repository, I would hope that important branches such as main are protected and have appropriate policies in place such that the developers don't have to make that decision, right? As far as where things go. But branch policies wasn't necessarily something I was going to dive into, but we're taking volunteers is what I heard. The other thing that's important to note, what
Follow up with you. You can do branch policy in a couple months.
with a rebase, because you are changing commits, anytime you end up performing an operation where you change that commit hash, it's going to require a force push because you've rewritten data and changed. And people get scared when they see the big red force push button in GitKraken. It's like, oh, force pushing bad. Force pushing means you are telling your remote, my version of history is correct. Take it. Don't use yours anymore. Right? You are basically saying, no, I know better about what actually happened. I've changed history. I've moved things around. And rebasing does require that force push. And for certain repositories like DevOps doesn't enable that by default for non-owners of a branch. Again, this is one of those things that is usually solved with policies on who can force push where. In general, developers usually should have permission to force push to their own feature branches. There's not a big risk there allowing it. But it is worth noting that you don't just like rebase your develop branch on main. That's something that an admin ends up having to do because hopefully those operations are locked down and not pushed through.
So perhaps spending too much time on this topic, I'm going to ask a question.
Fire away.
Do you think, is your opinion or your assessment, your analysis that this works universally regardless of, let's say, number of devs on a team, maturity of the devs on the team, type of work that's being done?
So type of work is interesting, and that might be one to explore deeper. I will say maturity of devs on a team definitely plays a factor into this. The merge commits tend to be, despite the fact that they make a weird, messy graph, they allow you to deal with the problem up front immediately without having to really think back. And so people who are newer to Git will usually find those to be friendlier to them. So I would say, I don't know if team maturity as much as team Git knowledge might be the key metric there for going through and doing it. I will say, for our hackathon, we had a team of 6 people. We had 0 branch protection policies, and with a few minor mistakes, we had a completely linear history with rebases all the way through, and it worked great. Oh, dear heavens, yes. Like I said, there was a couple mistakes, and somebody may have fixed them with a force push shortly thereafter. But other than that, our team actually did remarkably well doing it, and we ended up with a nice, clean, linear history. Is that important? Maybe, maybe not. Right? The idea of a nice, clean, linear history sort of implies that you want to actually go back and look at it later. Right? Sometimes, if you aren't ever going back to it, does it matter how messy the past is if you don't use it? It depends on where that's actually going. Like, how important is that?
It's clean, that's the key thing. I don't necessarily care about the feature branches and bug fix branches and any of the branches you come up with, as long as your main default branch from which you're gonna deploy stuff, as long as it's clean, that would be the key thing, right? Because I'm gonna need to know what, how did I get to whatever's in my test environment? How did I get to whatever's in my production environment, et cetera, et cetera.
Right. And in those cases, you are actually caring about how did I get here? That history matters. You're implicitly looking at it to know.
What is in the branch at this particular time, not how did I get there?
Okay.
I mean, it's not a blame game of, who screwed the thing up. It's where am I? What actually made it? What fixes made it? Et cetera, et cetera.
Right.
So,
And if you're squashing, then you're looking at that feature by feature. This feature gets added, and then the next feature, and the next feature, and that's
Right. You don't have that.
stays linear.
Correct.
You don't have that individual in the feature, the history of development.
Yeah, and I will say, as the person who loves his rebase, I definitely favor branch policies that squash PRs going into the main branch by far. I do not like keeping that history. Again, there's been cases where people have shown that history is important. The key question to answer is, do you care about the history? Like, that's the big difference. Are you rewriting history and changing it with things like squashes and rebases, or are you keeping the history? And again, there's not a one size fits all, and depending on the branching strategy taken. I will point out the link at the bottom there. GitKraken had a reasonable write-up on rebase versus merge. I think they actually came down slightly favoring the merge over the rebase. That's fine. I get it. I'm in the minority. I understand. I'll deal with it. But if anybody's actually interested in a good write-up there, they do also have a nice article written on various branching policies and the pros and cons there, if you are interested in that as well.
When it also override the author, you still track history using the author, who authored and when, or is only commit?
Yes.
In regards to like blank.
When you're like rebasing, in terms of like, hey, you want to track history, you might not be able to track it directly by commit, but can you still track it by authorization of those commits even after they've been rebased?
Yeah. So the question is, can you effectively track after something that's changed your hash via author or similar? The answer is yes, kind of, but it depends. So everything inside of your commit is malleable. Author, time. Like, if people want to, they can go and pretend like their commits happened 2 weeks ago, even though they're authoring them today, right? All of that stuff can be changed. Now, author gets to be a little more interesting because you can do things like signed commits, and then you can get a little bit more, yes, this person actually did it. But that requires actually setting that up. And if that's not set up, the author of a commit is whatever name they happen to type into their Git profile, which is great. So, which is why you'll oftentimes see, especially you can tell when certain people started adopting different tools, because new tool filed up, asks you to provide your profile information. There's one repo in particular, mine, where my name was Kevin B for a long time, and then got GitKraken, Kevin Bost. And so you will see, because the commits weren't signed, and the username is whatever I happened to type into the tool when I configured it. So you can kind of follow it, but again, it's about as trustworthy as the return address on an envelope. So yeah, you can use it, but you can fill it in with whatever you want. The other one that I wanted to call out was the cherry pick operation. And this is effectively, you can imagine in that exact same example before where we have the feature branch and the main, a rebase is effectively cherry picking those commits one at a time on top of your target branch. But you don't have to take them all wholesale if you don't want to. You can go through, duplicate, and basically clone those commits from one branch onto another. And if you want to replay them in a different order, buyer beware. You can certainly have all kinds of conflicting fun, but you can replay those same set of changes onto different places, which is oftentimes the key place where I end up using this is somebody's done some work and they go, oh, shoot, I actually committed that change onto the wrong branch. Oops, I actually want that change over here, right? I was busy, didn't realize I was working on feature branch A. I actually need this on feature branch B. These things aren't related. Okay, we'll switch on to feature branch B, cherry pick that commit across, and then go back to feature branch A and blow it away. Like those are things that make it very easy to be able to pull that. So understand that that is an easy operation. The other one is either stash push or stash pop for local transdiv stuff, but that doesn't work if you want to go against multiple machines, like across remotes. Like I will oftentimes, because I have a desktop that I do a bunch of work on as well as a laptop, so sometimes I'm pushing things up just so that I can use Git to effectively synchronize between machines and bring things back and forth. So you can certainly pull these things back and forth between them.
QA or prod branch and then taking that fix and pushing it into your main. If you don't want to take main and push it up, better always if you can get away with always go forward, but sometimes you've got to patch something.
So real quick, we're going to go here. There. That's not the right repo. There you go. That's the right repo. Thank you. Okay. So I figured at this point I want to actually show Git in action versus not actually showing tools. So once again, this is GitKraken. This is my tool of choice. So insert all the heavy bias things here. One of the key things to note is GitKraken does come with an integrated terminal built in. So people who would much rather do Git on the command line, but still want this visual graph, which I struggle using Git without being able to see this type of graph. Having the visual representation of what commits are where and their relationship to one another is completely invaluable. There's a lot of tools that have it. This one, again, is definitely my preference. But if you want to interact with your repository from a terminal and go from there, you can certainly do that as well. Just be aware that you may have to set up some auth and similar things in here. Just wanting to go and kind of show a couple things really quick just on that that feature branch. So here we have my master branch sitting here. I've got a feature branch here that we've done some work on. I also have a feature branch way back here that has gone through as well. So we're fixing the description of Kevin, and this is very similar to what you might expect with the difference between the rebase. So my master branch is the blue line here in the middle. Feature branch is the pink purple line that comes off to the side. So I started from master, made some changes, because I can't resist my Christmas squirrel. But this feature branch here with bug number 42, because that was the only bug number I could come up with, is now behind my master branch. So this would be the point that if both of these were trying to merge into master, the question comes, okay, which branching strategy is best? Do I want to rebase? Do I want to merge? Do I care about the history? Right? And you can see in this case, my main branch does have merge commits, adding things in here with conflict resolution, all kinds of other things pulled in. So If we want to, we can just take this guy and say, well, let's go ahead. We can either merge it directly, we can rebase it, we could start a pull request if depending on what the thing is. So we are going to pretend like pull requests are a thing and then going through here. So you know, merge conflicts detected, right? So if you want to actually resolve this, you got to stash any changes, check out the branch now. Okay, we're going to pass on that. And let's go here and actually show the rebase. So like you were saying earlier, Phil, having the rebase doesn't prevent the conflict. It just prevents you from needing to do it. So I come in here and I go, oh, okay, well, let's see. You know, is my name Robert Dr. Frankenstein or is it Kevin? Well, you know, in this case, the Christmas squirrel is great, but we're going to go with Kevin because GitKraken rocks, and that is the way of the future pushing it through, right? And then at the very end, teams get out of my way, continue rebase. And this would be the point where if you had multiple commits, that continue button would then start going through those commits one at a time. Oftentimes the commit will just auto move on to the next, assuming there's no conflicts, but then my graph changes, right? Before if I followed the line straight down from my branch, I would be coming down here and I'd be hitting this commit. Now rebased right on top. Okay. The other one that I think people often forget about is with Git, you don't need to be nearly as panicked about losing your work. People freak out about that in a lot of cases of going, I'm going to lose work. What is happening? Don't panic. I'm gonna save you. Play with Git. The best thing to do is to actually try it and do things, because if you don't do things, you never learn. So for example, I realized, oh shoot, rebase isn't what I wanted. I was told don't ever force push. Force pushing's bad. Now I've got this situation where my local branch here is now completely disjointed from my remote branch. So the little picture of me is my GitHub profile. The easiest thing is the reset command. So if we go reset, and then git reset has various modes, but one of them is hard, which effectively just says, pick the branch pointer up, put it here, don't think, don't do anything with changes, just move it here now. Usually git reset hard is a great way to lose work. And you might think that we've gone through and thrown away that other commit, right? That other commit used to be there, but this is a tree, and when you cut off all of the branches pointed to that, it's now orphaned. There's nothing connecting that other commit back to the tree. But we can actually get that commit back if we want. And this is one of those things that most people, yeah, so when we did the rebase, there was a new commit created with a brand new commit hash, right? Yeah, I memorized the commit hash, so we're good. We can get back to do it. But for those people who didn't memorize that long hash, the magical thing here is ref log. So, yeah, you know, spelling. There we are. And actually, hang on one second. I'm gonna make this bigger before I get too carried away. So, do that maneuver. So the Git Ref Log is a log of where all of your local references have moved around to. So you'll note in here, this is actually showing me several commits, some of which may be the relevant one. So you can see my original commit here that I was sitting on is B4F something, right? Here's my top one here. You can see that we also have other commits where finish returning refs to feature bug 2, where we rebased. So we can actually go and find prior commits. So if you are playing around on your local repository and you've accidentally orphaned a commit, moved something around and gone, oh crap, don't panic. Don't delete your local checkout, because that'd be bad too. But more often than not, this ref log is actually probably going to have exactly what you're looking for. So for example, if we grab this little commit hash here, and we're going to go here and we will do git reset -- hard, put in the commit hash. And you'll note My graph just updated, and I'm now back at that other orphan commit that was dead and gone a moment ago. So even though there's not necessarily a UI way to show orphaned commits off in the middle of nowhere, as long as you can get a hold of that hash, and as long as that commit still exists in your local repository, you can go ahead and get there. Right? So going through and doing it, this actually gets even more fun because we can, rather than just going by hash, we can reference things in various ways as well. So if we do Git Ref Log, let's do Git Ref Log show master. We can see that one there, but you can also tell it, okay, I want to actually see master. And if you look at the docs, it's really great. You can do something like master yesterday. And if you look at the docs, this is the command that they show you. This command was written for people not on Windows. Okay, so if you are running into a problem, wrap it in quotes, because what you'll run into is some characters, depending on what terminal you're in, are going to get interpreted differently. In this case, that at curly brace yesterday is going to get interpreted differently depending on what terminal you're on. So ensuring that it gets processed as a single argument being passed in. But then you can actually go through and start querying. There's a bunch of different syntax for doing this. And actually, hang on, I'm going to flip back because I think, nope, didn't make a slide for it. There are various ways to go through and specify that from yesterday, 1 day ago. You can do hours, minutes, various things like that to actually go through and do your history. So when you're querying this, you don't just have to say, show me everything in my ref log, because dear heavens, that could be a ton depending on how much you've been moving stuff around. You can start isolating down and saying, okay, I'm actually only interested in this ref, and I'm actually looking for this ref, 1 day ago or similar, right? What was I doing last Friday? Because I can't remember. It's been a weekend. My brain doesn't go back that far. There isn't necessarily built-in support anywhere for reflog that I'm aware of inside of the GitKraken GUI directly. This is one of those command liney things that is worth knowing about. Questions, comments? So the question is, every commit is stored always. Yeah, so that it doesn't grow infinitely. There are things like Git GC, garbage collection, that can clean stuff up. There's operations that will trigger it. The ref log is a log of reference changes. So going back to that early slide of what is a Git ref, of branch, tag, head, those types of things moving around, it will give you a log of those. It doesn't necessarily mean it's tracking everything, nor that everything's going to be stored for all time, right? But it is an easy way of getting yourself out of a bad situation, because I've lost work plenty of time and gone, oh crap, right? But once you get that Git hash, you should be able to reset yourself onto it, because as long as your repository knows about what that hash is, if you type in a random hash, you'll usually get I don't know what you're talking about. But if it's still there, it can pull it up, even if it's not something that's easily visible in the graph, right? And Git Ref Log is actually an alias to Git Log, and I'd have to check the docs. So Git Log is your generic show me the log of stuff, and Ref Log is an alias for Git Log with some options that I can't remember exactly in detail what they are. Git has a lot of options. Mm-hmm.
Would it show up in the ref log for another user? Is that?
Yeah, so the question is, if you orphaned a commit without ever pushing it, would it still show up in the ref log? Yes, that's actually what this one was here. We never actually, even though this is pushed remotely, it was still a local one. This rebase was never pushed. Correct. Yeah. So take this with a grain of salt because so the question is when does the stuff get cleaned up? I believe the answer is whenever Git runs its garbage collection cleanup, but there are various Git operations that will trigger the Git GC. And I would probably have to check the docs to know exactly what those end up being. Because running a Git GC on a repository that you've had going for a long time, you'll note your Git repository gets bigger and bigger and bigger as time goes on. And some of it is, yeah, you've added more stuff, you've made more changes, right? There's growth there because it has to keep track of that database of files that you've added and modified and all of that. But oftentimes you can Git GC and clean up a bunch of it. Of stuff that may be dead, gone, that doesn't need to be around anymore because you've done stuff locally. Some people just do the XKCD approach where I just delete my local checkout and reclone. That is an option. That is the nuclear option, though. That is the non-typically recommended option. The other thing that I wanted to call out is oftentimes people run into this issue of, hey, I want to figure out how do I view the diff of my branch, right? Like some people will go through and open up pull requests just because I want to know what's the diff between branch A and branch B. It totally works. You can do that. The magical command though in question is Git Diff is what you're actually looking for, right? Because Git Diff lets you go through and compare between so I'll be careful how I phrase this. I don't want to say commits or refs because it's actually bigger than that. Compare between two Gitty things is probably the easier way to say it because you can compare between commits, you can compare between branches, you can do a diff, a Git diff and provide various comparisons. So for example, if we go back.
They're all points.
Correct. Well, because a commit is a snapshot, right? The Git diff is going to end up doing that type of stuff, right? So if we do master and then how about feature bug 42, right? And so we can see that in this case, I'm getting a diff. And if you do this on the command line, you have to look at the diff via the loveliness, right? We can see, okay, there's a couple lines deleted. Robert, Dr. Frankenstein got deleted. I came in, GitKraken rocks, clearly. I mean, I think that's obvious to everyone. But you can actually do this diff either between your branches, between your commits, just being able to go through and see this. In GitKraken, it's even simpler. You highlight what you want, right? So I can either control click, or if you're on a Mac, command click, shift click to connect a range. You can get really fancy and say, you know what? What's that look like? Why? I don't know. That seems very unlikely. But if all you're looking at is trying to figure out, okay, what are the changes that exist here? Because you'll note in these three commits, all three of them modify the index.html file, but only one of them actually adds in an image, right? So we can look at this, and if we look at index.html, we see the sum total of all of the changes, right? So the image tag is being swapped out. We've got some text that's going through. But if all you're looking to do is see the diff between two Gitty things, whether those be refs, commits, whatever, Git Diff will save you a lot of time to be able to go through and look at that, especially if you want to, do it without actually opening a pull request. Now, I understand some people like the UI and GitHub or whatever, and sure, that's still an option. But if you'd like to do it without opening a pull request, this is the source of where all that information is coming from. Oh, that is a good question. So the question was, can you do the versioning syntax here? And honestly, I have no idea. So tell you in a second. Yep, works just fine. So yes, you can do that. I learned something new today. That's awesome. Okay, one other thing that I wanted to highlight as well is the idea of work trees. This is something that, unfortunately, it is the 4th highest rated item on the feedback for GitKraken GUI because it doesn't exist in the UI anywhere. If you use Git Lens, it has built-in support. A few other tools have it as well. Let's imagine the use case where you would like to have 2 branches on your repository checked out simultaneously. Right? I want to compare, what I'm doing on my feature branch versus what exactly is live on master. But I don't want to be toggling back and forth, right? I'm actively working on one branch, but I want to see where it is on the other. So I'll put myself back on here. So the solution to that is a work tree. Now, some people go to the route of, well, I'll just clone the repo a second time. That works. But that takes up a lot more space. You don't actually need a full second clone when the bulk of what's likely there is inside of your .git folder, which is your repository. If you do a full clone, you're getting a full second copy. Really what you want is just a separate folder at your branch that you can work in, but still use the same database for your repository. So solution. So git work tree, and then I believe it's just list. So you can see at present, I have a single work tree. And this is what most people are used to. In your main repository, when you open it, this is your working state. But you could have a second working state. Just like work tree, we can make work forest. So git work tree add. That's the wrong word. Let's try that again. Repo master, and then we will do this at my master branch. Okay, so I've created a second work tree. You have to give it a folder of where you want to put it. You do not want to nest it underneath your first working tree. That's a bad idea. So you'll note up a directory and over one to the side because reasons. And then you have to give it a git ref or a commit or something to tell it where do you want this thing to go. All right, and then we can go through and do something like open this in code. And now I have this VS Code open at my repo, and I'm just going to come in here and for lack of anything intelligent, I'm just going to delete my head because this is how you lose your head. Okay, save the file. And we come back here, and if we open that guy up, so this is unfortunate that it doesn't actually show you the, let's see, R. If you open that second work tree up that I created, you will note that it is on the master branch, and it shows one pending change with the entire head tag deleted. And I can now go through and interact with this as I want, as though it was a second clone of my repository. So I can make commits, I can push things. But you'll note the key difference here is if I look at my, did I close my VS Code? I think I closed my VS Code. Dang. Why did I close VS Code? If I open this guy up, I don't actually have, or maybe a better one is, yeah, repo master. Let's actually just open that up in Windows Explorer. Thinking about opening it in Windows Explorer. Okay, VS Code will work here, but no actual, we can just open the terminal. Where's my terminal? Terminal, what, open, show extension. Oh, it's going to go through and actually think hard and all of this stuff. All of this just so I can do an LS. Or you can take my word for it, and there's no .git directory. Thinking, I think between GitKraken and Teams. Yeah, I suppose you're right. This would have, There we go. Thank you. Yes, there is a perfectly good terminal right in front of me. But no .git directory. So you can end up being able to have those duplicate checkouts. I can do whatever I need to on my other branch. I can compare what's live on master, but I don't have to take the overhead of having a full second clone down on my thing. Just like git work tree add, there's git work tree remove. You tell it to delete it and it goes away, folder disappears. Again, don't put it inside your existing work tree. You'll get yourself into all kinds of problems. Absolutely. So yeah, so the question is, it functions as another, correct.
Copy all the files that make up the database at that reference point.
Yep.
So how does
So
it know from within that folder, how does it know that it's a Git repo without the .git?
how does it know that it's a Git repo without the .git? That is a good question. I do not actually, I might have to, I don't know how it gets the reference. I know how the parent knows about the child, but I don't know how the child knows backwards about the parent. I might have to look. So I believe the answer is yes, though. So, well, yep. So by magic, it works. So you raise a good question. I don't actually know, given the work tree in isolation, what the reference back to the main one is. But again, the important part is that the work tree is using the same database to power it.
Exactly. That's stored over in your original
Correct.
folder. Okay, and then I think my other question would be,
Was there a Git attributes on there?
there's a git ignore, a .git.
Oh, you are
I thought Git had-
there. Oh, there's a git ignore. Well, yeah, the problem is this is PowerShell inside of a virtualized terminal, and I'm trying to remember the get child item, but regardless.
I guess if you're actually making changes in two places, but it feels like you could just do a git diff or do a compare.
You could, but
It would functionally give you the ability to make changes in branch A and look at what master looks like or what branch
right,
B
but
looks like.
sometimes looking at the code isn't sufficient. Like the use case where I end up doing this is where, I'm working on my branch and I'm like, man, it's like, is this thing broken? Is this something I broke on my branch, or is this actually broken, or is this actually broken on main too, right? So oftentimes that's the use case where I'll do it is I'll work tree off main and say, let me run the app there, right? Because if I know the line of code to look at for the bug, yeah, I could probably git diff and blame and figure out, did I change this or is it different? But sometimes the bugs are not always that easy. Like it's not clear what change might have predicated this. Like, did I make a change that broke this? Is this something else? Yeah, did I just break this or is this something else? So oftentimes that's the use case where I'll leverage the work trees a lot, is to be able to pull that in and say, I'm doing this so that I can run the app, not necessarily because I want to, be editing two branches in parallel. Right? That's certainly a possibility, but yeah, my brain's messed up, but it's not that messed up. Yeah, I can't focus on that too much. One other slide I wanted to get to really quick before we dive in is actually cleaning up mistakes, because Phil had mentioned before, like on the last talk, on keeping secrets out of your repositories. And hopefully with a little bit of the ref log stuff pointing out that sometimes it's not always trivial to clear out old stuff. If you do actually commit something into your repository, again, with the secret stuff, the best remediation first is to go and cycle whatever secret you just checked in, right? Make sure it's invalid, but actually then getting it back out, or maybe you accidentally committed a large MOV file or an MP4 or whatever, right? It's like, oops, I didn't mean to put a 3 gig file into my Git repository. That's bad. And I skipped over the LFS stuff. But these are the primary tools that you would end up going through and cleaning these out. Both of these tools are going to go back because they are going to go through your history and change commits, effectively taking files out of those commit hashes. They will change all of your hashes and will require you to force push afterwards. So before running these tools, step one is functionally freeze the repo. And that can mean walking around to your teammates and saying, okay, everybody stop. No one move. We're about to do something big and destructive, right? But functionally freeze the repo because you don't want to be running these tools force pushing. If somebody else tries to do something first, you're about to force push over the top of everything. So their work all gets lost. And everybody needs to reset afterwards anyway. So just be aware, both of these tools exist. They've got good docs on how to do it. At the bottom, I've got links for both GitHub and Azure DevOps. Both of them walk you through sort of steps on doing it. I like the GitHub docs over the DevOps or the Azure DevOps ones. I found them easier to read, but functionally, they're both giving you the same kind of information. You've got either a secret file that you want to take out, or you've got a big file you want to take out. Here's what you got to do. So I think with that, I am right at time. So if people want more information about IntelliTech, there's that there. Thank you for coming. Again, if people want these slides, QR code in the bottom will give you a link to this slide deck with all of the links. I will leave this up so people can snag it. And if anybody has questions, I am here. Cool.
Yeah.
Thank you very much.